Analysis of age expectancy and body fat composition. Introduction. Purpose of the data: determining if there is a difference in average life expectancy between males and females. The data is compiled from 40 different countries and takes into account the different genders. Initial observation. The dataset was compiled of 40 samples with 2 relevant variables to be tested from each sample. The relevant variables being tested were male life expectancy and female life expectancy. A paired t-test will be used to compare 2 population means, male and female life expectancies, in 40 countries samples to test for an average difference in life expectancy. Very accurate data sets to accurately represent all males and females on the planet.
Analysis. The null hypothesis is that the average difference between females and males is equal to 0, where mu1 minus mu2 equals mu-d. The alternative hypothesis is that mu-d is not equal to 0. Mu1 represents female life expectancy of the population, and mu2 represents male life expectancy of the population. From the paired t-test, t equals 13.252, the significance level is 0.05, and our p-value is approximately 0.001. The p-value is less than the significance level, therefore we reject the null hypothesis.
Conclusion. We rejected our null hypothesis. Being said, females have a higher life expectancy than men, as indicated by the mean difference between male and female life expectancies. Retrospect and weakness. We have a large data set composed of 40 samples, so our conclusion or results should be accurate. The weakness, though, with such a large sample size is that there is a higher chance of error within the analytical procedure. Statistics analysis of individuals' body fat index in relation to different body measurements.
Introduction. The purpose of the dataset and the study is to determine if there is a linear model that determines the body fat of an individual in relations to a multiple independent body measurements. The sample size is compiled of 20 healthy female subjects. Initial observation. Dataset is compiled of 20 samples of 20 different females with 3 testable variables. Variables were tricep skin fold thickness, thigh circumference, mid-arm circumference. Use multiple linear regression tests to compare all 3 variables with the amount of body fat. This is used to find the best regression equation. Analysis. Null hypothesis was that there is not a correlation between the measurements of different body area and the amount of body fat in the subjects. Variables used were x1 and x3. The linear regression equation is y equals 6.79 plus 1x1 minus 0.431 x3. Our p-value was less than 0.0001, and our test statistic was 31.25. Our p-value that is equal to a number less than 0.0001 is less than the significant level of 0.05, which is grounds to reject the null hypothesis.
Conclusion. There is a clear correlation between individuals' body measurements and their body fat index. This is significant because it allows people to determine what parts of the body contribute most to raising or lowering a person's body fat index. Mid-arm circumference, x3, and tricep skin fold thickness, x1, are the most important variables for raising the body fat index. Retrospect and weaknesses. The sample size is so small that it is difficult to gain an accurate representation from the findings. The sample is significant because it can be used to determine what parts of the body are the most important in either raising or lowering the body fat index.